Hello, hello. How's everyone doing tonight? Hopefully, you're doing well. All right. So, tonight's class, running a little late as always, as always. Tonight, we are going to make something I've been needing to make for a long time for my household, specifically for my dog. We are going to make a dog food stand, basically, a elevated stand for her water bowl and dog food so that she's not hunched over and hurting her neck and everything trying to eat food and everything. She can stand upright and eat comfortably and all. And It's a whole thing. There dog food stands, you can buy them online on Amazon and all, but I wanted to add my little own personal touch to this one. And I thought, well, what better way to do it is to put it in a class and let's see if we can make it together. Now, how you going? How you doing, Blaze? Hey, Joseph, how are you doing? So many of you may have heard of before. Hey, Doug Fushi, how you doing? Many of you that are woodworkers, not just CNC woodworkers, but if you're in the woodworking world and on the woodworking world and YouTube and the old woodworkers of days old and everything, many of you are probably familiar with a woodworking engineer who's an absolute genius by the name of Matthias Wandel. And Matthias has one of his programs that he sells on his website is a gear generator. We're going to actually be using that tonight in a little bit of a different way. We're going to generate some gears for the design of this dog food stand. And so I believe that woodgears.ca, the website, he still has his gear generator program on there. I think I paid $25 for it or something way back when. I've had it for years, and it's phenomenal. It's great if you're making wood gears and wood clocks and all that stuff, which I don't do very often or anything like that. But I thought, you know what? I saw a very cool trestle table that basically the legs looked like two gears, interacting with each other and everything. And I thought, man, there's going to be a great way to, I think that would be pretty cool. So let's get over to the other screen. Let's talk about the project that we're making a little bit, and let's see what we can come up with. Hey, everybody, how are y'all doing? All right. And yeah, the cats are, yep, the cats, they're good. They can climb. But no, but this could work for your cats too. So there's different heights and different things. So it's animals of all sizes, basically. All right, let's get a look at what we're talking about tonight and see what we've got here. So the first things first is I want to talk about the bowls and bowl sizes, and then also recommended dog bowl height stands and everything. So let's talk about what is a dog bowl stand. You've seen them all over the place. They're all over the internet. They're all over Etsy, Amazon, eBay. You've got stands for dogs and cats, right? There's your two different heights and everything. You've got pretty cool stands that, for multiple dogs, or stands for a single dog, whatever the case may be. They could be fancy, they could be plain, but there are all kinds of awesome, cool stands, right? And tonight is no different. I'm making an elevated place for my dog to eat. I've already got her bowls elevated. She's a tall husky breed dog, and I've already got her bowls elevated, but they're just on little platforms, and it's not very secure. And so I thought I wanted to do something different. So this is what we're working towards. We're building a stand, but we're going to do something a little bit different. When I saw when I was looking at table designs and everything, I came across this image here. And this image, being a woodworker and everything, this trestle table leg, I mean, it just registered with me. And I thought, oh yeah, definitely want to do something along those lines and everything. And so that's kind of the look that we're going to go for the legs of this dog food stand. And in order to achieve this 2-gear look, or you could almost looks like a zipper, but it's actually 2 gears. We are going to actually use Matthias Matthias Wandel. We're going to use his gear generator program, and on the gear generator program, I've already set up the gears that I want. Basically, they're spoke gears with no spokes. I just want the gears themselves, and I'm not going to get all into it, but basically the contact angle on the teeth are going to be about 10 degrees, and each of these gears are, the DXF that I'm exporting out, it's a 25 tooth gear with a addendum of 3/8 of an inch. So it has a little bit of a reach in here inside, so it's kind of a little bit deep right there. And again, I'm using this, let's show the animation here. I'm using this for my leg design. So with this, I could change, the size of the teeth and the gears. I can change the spokes if I want, multiple spokes or things. Let's see here. Let's say I want, spokes on this gear, all kinds of stuff. So this gear gadget is pretty slick. Well, I don't want any spokes on this. And on the gear properties, I want the teeth. I want to set it for 25 because I'm going to scale it up to the size that I need and everything. But this is what I want right here. And so let's turn off the animation. We're going to go ahead and export this out as a basic DXF. And I've already got the gear leg file here. I'll just go ahead and overwrite that with this gear so you can just kind of see the saving there. And then in the Vectric software, I'm going to go ahead and set up my job. So on my job setup, right now, I want to, I'm thinking that I'm going to be using some sheet material, 3/4 inch plywood or something. So let's just, for right now, I'm not going to go 3/4 inch. That's a little too heavy. I'm going to go, is 3/4 too heavy? Let me think. Is 3/4. 3/4 is not too heavy for what I want to do. All right, so we'll go with 3/4, which is that is 23/32. When it comes to plywood, 3/4 is the nominal measurement. 23/32 is the actual measurement. And in the Vectric software, if you don't know that 23/32 is 0.71875, you can simply just type in the fraction and hit the equal key on the keyboard, and it will do the fraction to decimal conversion for you. These little boxes throughout the software, for some of you that are new or anything like that, within the Vectric software, every one of those boxes that you can type in a value, they're called calculation edit boxes. And which means you can use them like calculators. You can add, subtract, multiply, divide. You can do fraction to decimal conversion, metric to imperial conversion, imperial to metric, pi conversions, all kinds of cool stuff. So in this case, we want a 23/32 inch piece of plywood, which is 0.71875. And I'm just going to go, for right now, I'm just going to have a sheet that's 24 inches by 24 inches, just until I can kind of draw what I want and everything and kind of create what I want. Now, the top of the dog food stand is going to be solid wood. And I think that I actually want to look at the bowl sizes that I have. And so if we come back over to the website here, I don't happen to have one of the bowls with me, right? And I don't have a tape measure and all that stuff. So basically, this is the bowl here. And let's get over to here. Roughly, it's about 8.5 inches in diameter. And the height doesn't matter because it's going to sit into a hole. Now, there is a lip, and that lip is only, I want to say maybe 3/16, a quarter inch, if that. So I'm going to be making my hole slightly undersized so that it rests on that lip and everything. So I'll probably make my hole about 8.25. And then, of course, before I actually cut it, I would double check, make sure, get all my measurements, all that stuff right. I just don't have tape measure of the dog bowl here with me right now. But that's what we're going to go for, is our 8.25 size, and we'll go with that. So with that being said, if we look at, some of the dog bowl stands and everything, you can see that, some of them are wide, some of them are narrow, some of them are this, some of them are that, whatever the case may be. And they're, depending on what you want. I don't want a big old table platform that my dog has to reach over and all that, but she does have a decent sized neck. She's a beautiful shepherd type dog. But with the bowl being about 8.5 inches in diameter, the bowls, the two bowls, about being 8.5 inches in diameter, I'm going to have the top around 11.25, basically a 1x12. Let's think of it like that. And so that's going to be a completely different sheet. So I'm going to be setting up another sheet, board, in this case sheet, but this is going to be my stand top. And it's going to, I don't know what the length is yet. We'll figure that out when we get everything I'm going to draw everything out and lay it out. But we're going to go in and edit that size. And I know that the width of the board is going to, how wide the board is going to be 11.25. And it is going to be a 3/4 inch board. Yeah, 3/4 is going to be fine. So 0.75. And that will be, I will be cutting through this one. So I'll reference off the machine bed, and I'll start from the bottom left corner for that. And then on my main sheet here, the legs, I could glue up a panel. Once I'm just right now laying out the legs so you can see what my plan and thoughts are and stuff. I can change, and instead of, I might not want to use plywood, I might want to use solid wood and just glue up a panel, depending on what size the panel needs to be and all that stuff. Or I could just probably make it right out of my 1x12, because it's going to be slightly less than the size of my tabletop, right? So all of that stuff. But for right now, I'm just creating this 24x24 area to work in. I just want to work in something, right? I'll fine tune the size in just a moment. We don't need that. So with that being said, I'm going to import that DXF gear. So I'm going to import that gear file, that DXF. Here it is here. And I don't need the grid. So I'm going to get rid of the grid and everything. Let's see. Let's just do this. Delete those lines. Select the light, that line. And on the lines that they get imported, and they're not true circles, they're more kind of like a polygon and everything. So I'm going to recreate those circles. And so this circle is about, right now, its current size, I haven't scaled it up or whatever and all that stuff yet, but it's about 7.5 inches. And so I'm going to come into my circle tool. I'm going to come in here and create a 7.5 inch diameter circle. I'm going to snap my mouse right to the center of this and click once over here. And I'm going to do the same thing on the left. And then I'm going to zoom in. And I want to get rid of the circle that's not a circle, right? The polygon, the one with the sharp points. And so I have that. And this one, I already had accidentally deleted that polygon, so that's good. Now I want to actually offset that inward another ½ an inch. So I want to create a 7-inch circle. Now I have two choices here. I can select both of these vectors, and I can offset them inward ½ an inch, right? One way to do it. Or I can use the circle tool as well, create the size of 7 inches. And again, I could come in and put my mouse in the center and just left click once, left click again, right? Either way, both get you from point A to B. Okay, cool. Now, my chair's creaking now. What I want to do now is I want to kind of connect these, and I'm going to use a keyboard shortcut that's I don't see a lot of people using it and all, but of course I'm not sitting over your shoulder watching you design things and all, but we're going to be snapping to the tangent of these circles and all. So I'm going to focus on the inside circle, and I'm going to come over here with the polyline tool. And I'm going to snap the line to the center of this inside circle here. And then I'm going to come over and I'm going to hover the mouse over here and just hit the letter T on the keyboard. And that's not the right tangent. So let me undo that. I need to make sure that the mouse is touching the circle that I want. Hit the letter T and it's going to snap to that tangent. I'm going to go 90 degrees down and click on that inside circle. And then I'm going to hover my mouse and T for tangent. And then I'm going to come up and finish off that rectangle there. Okay. Now I'm going to offset that rectangle. I'm going to offset that rectangle by ½ an inch. So I'm going to take that rectangle and I'm going to offset it outward by 1/2 inch, sharp corners, and create an offset. And I went the wrong direction. I went inward. I need to go outward. Perfect. And I'm going to take this outside rectangle. I'm going to hold the shift key down. I'm going to grab the little sizing node here, and I'm going to pull it out. And with the shift key down, it keeps it centered. So I'm going to pull it out slightly, right about here. And now I'm going to start to trim some things and connect some things and all that stuff. So the first thing I want to do is I want to get rid of any of my excess. But before I do that, I actually want to connect from the corner of this rectangle straight across. I'm going to come in here. And I want to come in straight across at a 0 angle. Let me get to my 0 angle, but I want to snap it to here. Space bar to finish. And I want to do the same thing over here. I want to kind of come straight across, make sure I'm at my 0 angle, and space bar to finish. I'm going to kind of connect that together because now I'm going to take my scissors, but before I take my scissors, I want to size this up. Now, this is not the right size that I want just yet. I want to kind of get the height that I need and all of that stuff. So we'll do some stretching and all. But right now, overall, let's not do the top of the gears, to the top of this box right now, in the bottom of this box, it's only 8 inches tall. Okay, and so think about on the 8 inches tall, I'll probably have another platform that will be another ½ inch at the bottom for the bottom plate. And then, of course, my top plate will be that 3/4 inch material. So if I'm at 8 inches and I'm another ½ inch, and then another 3/4, that's 9 1/4. And that would be my overall height. Well, let's go look at our chart once again, really quickly. And let's take a look at dog bowl stand heights, you know, kind of like some recommended heights and all that wonderful jazz. When it is, it's hard to see. Let me see if I can open that up in another tab. Let's see, we can get that a little bit bigger. There we go. And so basically, you know, when you're measuring for your bowl stand or whatever the case may be, you're going to measure, you know, from the floor to the back of the shoulders and stuff. And the shoulder height is going to kind of somewhat dictate the overall height. Now, Lainey has, she's quite a tall little girl, and she is, she stands, her back and everything, I believe she's between the 24 to 27 inch range. I think 2023. I haven't measured her in a while, but she's laying down and sleeping right now. I don't want to disturb her. But I'm going to say that for right now, let's say that she's between 20 to 23 inches, just as an example. I can resize it later, but that's going to kind of give a recommended height of about 10 inches for that stand and everything. So between 10 and 12 inches, right? Somewhere in that realm. So that kind of tells me, like, if this is going to end up being a leg system, which you'll see in just a minute, it'll look pretty cool. But if this is going to be a leg system and everything, then I want to kind of make sure that I'm, you know, right about that size. So what I'm going to do is I'm actually going to size this whole thing up. I'm going to select it all, and I'm going to scale it up. So let me just scale this up. Okay. And I'm just, for right now, I'm going to draw a 3/4 inch rectangle, and I'm going to draw a 1/2 inch rectangle. And this 1/2 inch rectangle, let's pretend that that is my base, kind of a base plate. And let's pretend this 3/4 inch rectangle is the top of my plate here, right? And so right now, if I were to measure from the top of that plate to the bottom of this rectangle here, we're sitting at about, that's not the right thing. Let's go vertical instead of horizontal. That might make some sense. But we're sitting, you know, right about, 10.7 inches here. Okay. And so that gets me right in that realm of that 10 inches, and I'm good with that. I don't need to size anymore. So that being said, I'm going to go ahead and let's get rid of the two rectangles for right now. We'll come back to those in just a minute. But now I'm ready to trim this leg to create this cool design and everything. So let's take the scissors and let's do some trimming. But before I do, let me connect the top here. I connected the bottom, but I forgot to connect the top. So I want a straight line to here, spacebar finish, a straight line to here. All right, now I'm going to take my scissors and let's, I'm going to hold down my left mouse button. And if I just cross over the items and everything, they will, the lines will disappear. You know, I don't have to click, 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 you know. And if you're in an older version, you do. But I think it was like version 10 or 10.5 on, they created where you can just cross the scissors over the line and it will cut, you know, kind of cool stuff. All right, in here, first thing I want to do is I want to get rid of this outside circle right there. I want to get rid of these lines in here. Get rid of this line and all of this in here. I want to get rid of all of this for right now. Don't need any of this stuff in the middle. Don't need any of this. None of this. Okay. I don't need this or any of the stuff inside of here. All right, now in this situation and everything, I'm actually going to make this out of one panel. So it's going to actually be one piece and everything. So I need to connect this together. So I'm going to kind of click here and here. And I'm also going to get rid of this. And I'll keep that one. I'll keep that one. Down here, I want to connect that and that. And this will represent one of my legs, okay? And so in here, I need to connect this right there. So let me take the scissors and connect that. Let's see, anything else? I want to get rid of this. I'll leave that. I'll leave that right there. That's fine. So this is going to be one of my sides. And if, once again, if we look at our reference photo and everything here, this is what we're going for, right? And this is that bottom plate I was talking about. Then, you know, there's going to be the top plate is going to be the table and all, but that's kind of the look we're going for, right? And but I'm not doing a double leg. I mean, this is a dog food stand. I'm probably just going to go single legs and everything. If I was going to go double legs, that's fine. I would create a couple of little places to where I can connect them together with something cool, like a small block of wood or something and all, if I was going to go double legs. But if I'm going 3/4 inch thick on the panel and everything, that's going to be enough, because there's going to be the trestle that crosses it and all that stuff. So, but that's our reference photo, right? So that's what kind of going for here. So that's what we got going on here. So we're looking at an end view of this leg and everything. Now, on here, it's not done yet and everything. I want to create basically little tenons, if you will. And I want it to where I, on the tenons and all, I will have matching mortises on the upper panel and the, you know, the bottom plate and stuff. Now here, since I'm going to be doing a bottom plate right here, I can actually eliminate or kind of connect or kind of separate the area right here to where it's open right in here. I can do that by I can do that a couple of ways, but for right now, I'm just gonna straight leg it right here. Just gonna straight line it, not straight leg. I'm just gonna straight line it. You know, I could always back up. Let me cut that here. I can always back up as well, and, you know, see if I want another tooth or something at the bottom there, or whatever the case may be. But in this situation, now this line's a crooked line right here. You see that? So I want to go into node editing, for node editing. I want to align to this node right here. So I'll select it first. I want to move this one. I'll select it last, hold that shift key down, and I need to move left to right. So that's the X axis. So if I hit the letter X, it'll pull that line straight. I believe this one is fine. It is. There's no crooks or anything in there. So that will be my separation there for the legs. Now, like I said, I'm going to have a bottom plate that's going to be, you know, a decently wide plate. I would say probably about 3 inches wide. And it's just going to go, let me see if I can simulate this. It's going to be a 1/2 inch thick, 3/8 inch or 3 inch wide. Give me just a second. And it's just going to be, you know, this plate here is just going to be 3 inches wide. And this leg assembly here is going to have tenons. We're going to cut some tenons in there, and they're going to go into some matching mortises on there to get, glued in, right? And the same thing with the 3/4 inch top. That 3/4 inch top is going to be 11 1/4 inches wide by 0.75. Now, it's important that my gear and foot and everything in there match my, my top. Remember, my top is a 1x12 that I decided with. So I need to make sure that I get my height and also my width and all. So this long span here, I'll probably end up cutting that out. But let me get this centered. And I want a little bit of an overhang. So let's imagine, if you will, that will come right about here. Well, that line is selected. I'm going to go ahead and mirror that line to the other side. My project right now is centered, so it will mirror. I'm going to create a mirror copy and flip it horizontal. And I'm going to go ahead and trim off. Whoops. I need to ungroup it first. U for ungroup. Let me move this up so you can see. I'm going to trim off this edge here and this edge here. Okay. And once again, on that top, I'm going to have tenons that are on the leg piece that go into matching mortises on the top. And the top is only going to have, it's going to have the 2 holes cut into it for the 2 bowls, and then the 4 mortises, right? So that's all on the top panel. That's all that's going to get cut on the CNC. The 4 mortises, the 2 on this end, 2 on the other leg, and then the 2 holes, right? And both bowls are the same size, so we're going to go 8 1/4 inch diameter holes, and that's going to be on the other sheet when we get to it. That top sheet, that's going to be our layout and everything. Now, the measurement, the numbers and the measurement on my tenons, I need to know that before I start working on that sheet as well. So are you following along? Are you guys and girls tracking with me so far? Is everything tracking so far and stuff? And I don't know if I want the base to be so wide out since the top is so short, right? I want the base to be a base, but it doesn't need to be like crazily long. So I'll probably end up bringing this down as well too. Right now I've got that base at 14.7 inches. Let's bring that down to let me see something here on my inspo pick. It's about as I'm guessing to say it's probably about as wide as it is underneath at the top as well too. Can't see the top or anything like that, but I'm guessing it's going to be probably just about as wide. So I'll probably match that. I can come in here if I want to, and I can bring a guideline in on each side, which will show me where to draw my lines down here. Either one, it doesn't matter. Or I could have just hovered my mouse here, and it would have given me a dotted line, when I was drawing down here. Either one would have worked with that smart snapping and geometry snapping turned on. So and then let me move this out of the way. I can turn those guidelines off now and just take the scissors and trim that away, right? Now, on here, when I am snapping to this, I will align it since it's already centered on my material. I will align it left to right, and I will hold down my shift key, grab it here, and I can size it in, and whatever I do on the left, it'll do on the right. And I just want the base plate to be slightly past the leg. And so what I'll do is that's 11 inches right there. So let's just match it up and make it 11 1/4. Kind of make the, No, I don't want to match it up. I want it to be just a little bit undersized. So let's go with the I'm going to go 10 3/4. So I'm going to go to the size tool, and we're going to change this size, unlink the X and Y, change this to 10.75. Make sure I'm radiating from the center so it spans out in both directions there. And that'll be my base. Cool beans. All right, so that's going to be one of the legs, or kind of like a simulation of one of the legs. All right, so now if that's the case, and let me move this down here. Now I need to figure out how long, how wide my tenons are going to be and stuff. And so the I don't want a small tenon, a decent sized tenon is going to be fine, but the tenon is going to there's going to be a shoulder cut, on it and everything. So this is going to technically be a two-sided job, and on the flip of the two-sided job, it's basically just to mill off the two faces and all to kind of reduce the size of my tenons, right? That kind of thing. All right, so what I want is, let's say that I'm just going to do one tenon. I will center it on this line here. Let me see how wide I want it. One inch. Let's go 1 1/4. So I'm going to go 1 1/4, and I'm going to go 3/8. 1 1/4 by 3/8. Now, notice that when I drew that, when I sized it just now, it pushed it down, because in that size tool, let me go back to the size tool. In that size tool, the rectangle tool, sorry, I had the top anchor, the top corner selected, so that when I sized it, it pushed it down and kept it snapped up against this edge here. Now I want to center this, so I'm just going to grab it, and that way I can just kind of come in here and snap it right to the center there. And again, since I'm centered, I'm just going to mirror that to the other side. Okay. Something. All right, is something not centered? Let me make sure that I am centered on my board. I am centered. Oh, I know what it is. It's two different. The gears are offset, so they mesh with each other. So it is. This is shorter than this over here, and that's by design. So that when I mirror that, let me mirror that again. It looked like it was off center there, and that's fine. What I'm going to do is I will mirror it. Oops. Make sure we don't have everything selected like that. Just that part right there. I will mirror that, but I'm actually going to snap it to the center of this line here. Okay. There we go. Yeah, that's by design. This leg right here is longer than that one because the gears are offset, of course, so the teeth interact and blah, 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 and da-da-da. Okay. And I probably, like I said, back when I trimmed, everything on the gears and stuff, when I was trimming them, I probably could keep one of the extra teeth down here, or at least the shape of it, maybe half the tooth, probably here and here and everything, instead of straight lining it down. Either one. If I wanted to correct that visionary, situation, I could come in here and re-import that the gears, move them off there, And I could, let me get rid of all this stuff. If I wanted to resimulate that, this radius right here, if you recall, I had a 7-inch, 7.5-inch circle, which created the clean circles here. And on the old one, get rid of the bad circles. And on the size, this here, these circles here, they were offset, if you recall, they were offset inward, 1/2 inch. So I'll offset them a 1/2 inch inward. And those outer circles ended up getting deleted with all the trimming and all that stuff. But on the gears here, this radius, if I measure, bear with me. Yeah. Measure. Are you going to give me a hard time? I don't know why that's not seeing it, so I'll just use this so it does see it. And that radius is, come on out, stop. It is not going to recognize that. It's not going to recognize my radius. I forget what size I had made that, but let me get things centered here. Okay, roughly just about something along those lines. The long story short is where I straight lined it. If I wanted to create that tooth, I could recreate that, or I could back all the way out. Whatever you want to do, whatever you want yours to look like, right? I'm not going to overcomplicate this, but you can either back it up, or you can, bring in the gear again, size it up the right size so you can create that tooth, all that wonderful jazz. It's not necessary for what I want. All right. So here, what is necessary is I need to connect these tenons together here. And let me get this out of the way for right now. On this, now you folks, for those of you that have been carving sometime for a while and all, you've heard of dog bone fillets and T-bone fillets and all that wonderful stuff. For those of you that are new, yeah, you can do a dowel pin, Blaze. Dowel pin is fine. Yep, you sure can. I want to do mortise and tenon joinery and everything, but a dowel pins is fine as well too. For those of you that are new and everything, let's talk about what a fillet is. Okay, and let's say that in the fillet tool, I'm doing a normal fillet. And let's say I'm doing a fillet of a 1/4 inch in radius. When I hover the mouse over one of the corners, it's going to take that sharp corner and it's going to fillet it. It's going to round it over. Okay, so we're creating those fillets and everything. Well, Dog bone fillets and T-bone fillets are used when it comes to joinery. And so let's say that I have a mortise, and let's go this way for right now. And I have a tenon that's going to be fitting into it. Now, depending on the joinery and everything, we can't fit a square peg into a round hole. And if I were, let's say that this was my tenon or my mortise pocket and everything, and let's say that I was using a 1/4 inch diameter bit to cut it and everything. So when that bit comes in cuts, it's not going to be able to get into that mortise and all. It's not going to be able to get into that corner. It's going to, end up radiusing that corner off. And so if my tenon isn't rounded off or radius to kind of match it and everything, then again, it's like fitting a square peg in a round hole. Well, what a dog bone and a T-bone fillet do is they give an area for the bit to kind of release to. So if I came in and let's make this a little bit wider, but if I came in and did a dog bone fillet on this corner, if I'm using a 1/4 inch bit, my radius would be 1/8 of an inch. The radius of that bit would be 1/8. And I would come in here and be able to create that dog bone fillet. And when you create the dog bone fillet, it looks like a dog bone. That's why they call it that. And that gives a place where two things. My square peg, and let me create my square peg here. My square peg can still fit into this mortise, and there's a place for my corners to go, right? And I have a place for my flat faces to go as well too. So if this peg was inside this mortise, that relief cut, that dog bone fillet, gave a way for the bit to kind of escape and all that wonderful jazz. Okay. And so that's a dog bone fillet. And a dog bone fillet is used when to create that relief so that the two slots fit together. But the other fillet, the T-bone fillet, is used to create that same relief when the slot is the same size as the router bit. Generally, that's kind of the general rule. So it creates that internal relief when the slot and the tool are the same size. So you might use the option of that T-bone fillet versus the dog bone fillet. But the only thing about the dog bone fillet is the unsightly exposure of these little holes. And so if we went online, for those of you that are new, that have never really seen a dog bone fillet, fillet joint, and we go look at the images and everything, when the two parts come together, that's really small. Of course, that's even smaller. Come on, dude. Give me a photo. Give me a photo. All right, this will be a good example here. It's not the example, but it's a similar example. But the little that little offset, the edges of that offset are kind of exposed, when the joinery occurs and everything. Well, we want to hide that. When I put my mortise in my tenon and everything, I want to hide that exposed radius. So on the tenons here, if I do a dog bone fillet on these inside corners and everything, when this part gets glued in, it's going to expose. There's still going to be that little bit of part of exposed, and it's just aesthetically, it's not pleasing at all, right? I don't want to see that with the dog bone fillet. So when those two parts are glued together, rather than a dog bone fillet, and y'all might say I'm pronouncing the word wrong, but Fillet, it's fillet, whatever. Rather than a dog bone fillet, I'm going to use a T-bone fillet, and I'm going to put a T-bone fillet on this face here and this face here, so that when the two parts fit together, number one, my router bit, when it's cutting out this part, it has a place to go to turn that corner. You know, for that inside corner, it has a place to go when it's making that cut. And my mortise will be cut into, you know, here and everything. And so when it comes in and joins together, that T-bone fillet will be hidden inside the joint. It'll be hidden inside the joint. So you won't see that unsightly, you know, dog bone, that little hair and all. So I prefer the T-bone fillet on my tenons, you know, going into the mortise area and all that. So basically, I'm going to be using a 1/4 inch end mill. So on that, actually, I'm not going to be using a 1/4 inch end mill on here because I need to use the smallest bit as I can to kind of get into some of these areas and stuff. So I'm going to be getting really down real small to kind of clean up some of those areas. And some of the areas are going to be so small that I'll probably have to do a little bit of Dremel work and all that wonderful jazz. But I'm actually going to be using an 1/8 inch end mill. So that's going to create a radius of a 1/16 of an inch. And so if we come in here, we'll get rid of that and put it in there again. Get rid of that, put it in there again. And I want it here. Now, when I put these in, if I click on this face, it's going to push it up, right? If I click on this face, it's going to push it in. And I want to click on this face. I want to push them in, okay? So I want to make sure that I'm on this line when I click for that. And the same thing is going to happen up here as well on my tenons that are going to be in the top. Same thing is going to occur. So where do I want these tenons? And again, they could be dowels, dowel pins as well, whatever you want. So let's say that I want, I'm going to go the same 1.25 inches by 3/4 or 3/8, not 3/4. And let's drop that one. Oh, come on, dude. I'll drop that one there, and I'm going to mirror that to the other side. Let's move this board out of the way. That represents my top panel right there. We're going to connect this. Oh, all right. So now here, it wants to delete that line in the middle when I'm clicking the scissors and everything. It's not wanting to connect here. So I'm going to simply take this rectangle and just give it a little bit of an overlap, pull it down, not changing its location and everything. So that way the software can see it as two separate lines, right? And so I can trim that away. And then once again, on our fillets, they're going to be that inside fillet there. Okay. Now, this is going to dictate, since this board right here represents my 11.25 board, right? This is going to kind of dictate where the mortises need to go and everything on my other board and all. And so I'm actually going to take and draw a line that way. I have a place that I can take measurements off of and everything. And the same thing here, This is still centered left to right and all that stuff. I'm just going to take a line from the center, kind of just draw it into that panel there. 90-degree line. And that gives me a reference line for where the tenons need to go on my 1/2-inch piece as well. And so on the 1/2-inch piece, it's just going to be those two tenons. And also on the boards, on my sheets, we're going to do another sheet that's going to be, and I'm going to go solid wood on the top and bottom here. So the next sheet is going to be for that bottom piece. And remember, I said it was 3 inches wide. That's going to be, so a 1x4 is 3.5 inches wide. So it'll be just kind of a 1x4 material. Let's go with I'll just go with a 12, because if you remember, it was 10 and 3/4, I believe. But we'll go 12 by 3.5 by 3/4 inches thick. Or no, sorry, 1/2 inch thick. I only want a 1/2 inch on the bottom. Again, I'll be referencing, I'm cutting this part out and everything, so I'll be referencing off the machine bed and all that wonderful jazz. So bottom left corner, we'll click OK. Now, I'm simply going to take these two vectors here. I'm going to move this vector over to the stand top sheet. And I'm going to move this vector over to the other sheet, which I did not name. It's just still sheet 2. I'll just throw that over there. I don't need that. That's trash. And here on this, now overall, this overall size right here is really, it's only 10 inches, 10.25 inches tall by 9.8 inches wide, 9.7959 inches wide. So it's wider than a 1x10, but if I wanted to make these legs out of solid wood as well, instead of plywood, I know I want two contrasting materials. I'd like to have my top be a different, material than my legs and everything. And my base plate could be the same material as the foot plate, could be the same material as the leg, or it could be also the other species as well. Aesthetically, whatever looks best, but now that I have this size, I know what size board I can get. I need 2 of these and everything out of a board. So I am going to go with another 1x12. I'm going to change this sheet that was going to be plywood. I'm going to make it out of solid wood out of my 1x12. Let's go ahead and edit this sheet. And we'll rotate it 90 degrees so it fits, but it's going to be 11.25. And I need 2 of these, and they're 10.5 inches tall. So 10, 21. So let's just go 24 by 11.25 by 3/4. And I'm going to rotate this because I want which way do I want the grain running? Vertically. I want the grain running vertically. So yeah, I'm going to rotate these. Go to the alignment tool. Mirror that. Something along that line. Get those centered on the board. So that'll be my 2 side pieces. Now, we're still not done drawing the side pieces. Let's go back to not our inspo image, or not our inspirational image, which was this image here, but let's just go back and look at in general, a trestle type style table, right? The center rail and everything. Well, in our center, let me bring myself up here. In our center, we have those teeth gear, right? The gear teeth and everything. So I don't want something running down the middle of the teeth. Where that leaves me is on the two gears that are coming together, on the two sides, it leaves me an area where I can have, maybe a front rail and a back rail, one on each, gear, running from front to back. And I'm going to have them, instead of straight up and down, there might be just a little bit of a slant inward, right? And so let's see here. Let's go back up to the top. Top. I don't really have a good example. I love these engineering style legs and all that stuff, but in this scenario, they could be straight, they could be angled, they could be whatever. Now, this is just a dog stand. I'm not going to get too fancy. I think I'm fancy enough as it is with the little gears and all that. But I don't want it running across the floor. I do want them up. I want the 2 feet to be 2 feet. I don't want a board running across the floor that could cause any imbalance if my woodworking skills aren't up to par, right? So they're gonna, it's just gonna have that span, but I can't go the middle, so I'm gonna go down each side and everything. So with that, let me turn these just really quickly. I'll relay them out in a minute, but let me turn them upright for just a second. And so here is where I'm referring to. I don't want something coming down the middle because I don't want to screw up that aesthetic, that look that I'm going for, right? That look that I'm going for and everything. If I were to do that, if I were to do a one centerpiece and everything, it would be somewhere, I would do a small, some kind of support somewhere right in here to where, it's not, I can still get the effect of the 2 gears and all that, but I'd like to just, let me come in here and let me take a 1/2 inch wide board that is, I don't know, 1.5 inches, 2 inches. Let's go 2 inches. And let's come over here. Let me center these really quickly for myself. Make sure they're centered because I want to use guidelines and all that wonderful jazz. So I'm going to come down here on the guideline, and I want to pretty much right there. And so on here, if I'm going to do that, I actually don't need to go at an angle. I thought I would be right on the curve, I thought I'd be on the curve where I'd have to angle them slightly one way or another, but I can actually fit, right in there, straight up and down. So it's going to be important for me that I kind of center on these two. And again, aesthetically, I don't want just on one, because this is one leg. I want the 2 running kind of parallel. Now, I could do a wider piece and then just have the 2 tenons on the end that are that are separated to where they fit into the mortise. Let me get that. I'll get that sized and everything in position where it belongs. That guideline doesn't belong here or here. That's an old guideline. But I'll get those centered in just a minute. But again, I could have one solid beam, but on the ends, the tenons are there that go into the, the matching into these mortises, or I could have two separate boards, or blah, 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 whatever you want. Now, if I was doing this, it would technically, I'm not going to sit there and try to cut, handsaw tenons and everything on the end. I would have three boards, two longer, one shorter, glued together, sanded, so the glue lines and everything disappear, so it looks like one beam. And I would just make my tenons that way, right? That kind of thing. I'm not going to try to machine them or handsaw them or anything. I just need to make sure that my material, when it all gets, glued together, it comes down to the right size. And if I do have to machine something or run something through the table saw to bring it down to size on the outer edges to clean up the glue and all that stuff, whatever. I'm a woodworker. I can do it all, right? That kind of thing. So, but let me give it in the chat. If y'all are with me in the chat still, solid beam, two separate beams. What would you, solid beam, two separate beams. What would you do if it was you? And I say beams like this is going to be a big table. I mean, the damn thing is only going to be 20. The table itself is only going to be like 24 inches long, 24 to 30 inches long. It's not like it's not like a big table, right? But this concept you could do a big table. Just got to go bigger and solid wood and all that stuff. But this is a dog stand, right? So would you do a solid piece with two tenons or two separate pieces? How would you do it? Throw it in the chat. Let me know. All right, now I want to make sure that I'm centered here and everything to the best of my ability. And so I'm going to kind of pick my battles and everything here. And so I'm going to use guidelines to kind of help me here. And whatever my measurement is here, I'm going to match it over here. So on the guideline over here, I'm going to match the space between the guidelines to match this. So if I come here and I measure horizontally from this guideline to this guideline, we're about 0.9091. Fair enough. Okay. And so here, I'm going to right click on this guideline. And I'm going to create a relative guide negative because I'm going to the left, 0.9091. Okay. And now I'm going to draw a line from this guideline to this guideline. Let's try that again with a straight line, not a crooked one. And I'm going to do the same thing here to here. Now, by drawing that line, what that does is it gives me a virtual center point, okay? So now I can select this rectangle that I want to align. I can select this line, and I can use my alignment tool to align to the center of that part, or of that line. Same thing here. Select the rectangle, select the line, and I can align to the center of that line. Once that line has served its purpose, then I can delete that, right? So just using it for spacing, all that wonderful jazz. Okay. Now, on here, these mortises are going to get cut on one side. I'm not going to do a through mortise. I'm just doing, it's going to be a blind mortise and everything. Exactly. Don't do through. Exactly. I'm not going to do through tenons. Thank you. I said through mortise, but I'm not going to do through tenons. It's going to be a blind tenon. So, but it's still going to be, I'm still going to be pocketing a mortise here, and I'm still going to need my fillets. Now, in this situation, it's not going to be the T-bone fillet. It is going to be the dog bone, But the I still have to make my tenons or my mortises to match the size of my tenons. And right now, you'll notice something that I did here. These rectangles are the same width, 1/2 inch of my board. They're not showing the shoulder cuts and everything. This is the size. This here is the size of my board that that's going to have the tenon on the end of it that fits in it. This is not the size of the mortise that I'm cutting and everything there, because the tenons are going to have shoulder cuts and face cuts and everything. So so this represents my 1/2 inch board right here, 1/2 inch wide by 2 inches tall, and my actual mortise is going to be in from the size of my tenon. So here I'm going to offset these inward. And I'm going to be using an 1/8 inch end mill that's going to give me a 1/16 inch radius and everything. So I want to go inward slightly more than a 1/16 of an inch, right? I want it on my shoulder cuts and everything on my tenon. So I'm actually going to come inward a 0.08 square corners offset. Yeah. And when I put my fillets in here, these will be dog bone fillets on this one. When I put my fillets in here, I'm going to be using an 1/8 inch end mill. And when I put the fillets in here, not the T-bone, undo that, my dog bone fillets, they're going to be here. But again, when the tenon is glued in, the actual board is going to cover those holes. So you're not going to see those little dog bone, those little openings and everything. You know what I mean? So they're going to be concealed by the actual material. And then on the tenon itself, the 2 T-bone fillets will be concealed because they'll be inside of the joint, in the joint. All right, so let's go here. Y'all tracking with that? Y'all understanding what I'm picking up, what I'm putting down? All right. Now, so you don't confuse the situation all, once you get your tenons and everything laid out, you can get rid of those, and that's going to be your tenon pockets vectors. Now, these two parts are identical. Why draw what you can copy? I'm going to delete that one, and I'm going to hold down the control key and drag a copy out here. Now I've got my two, mortise pockets of vectors and all. I can go ahead and lay these back out. So let me rotate. I'm using the number 0 key on the keyboard. And hold on a minute. Very important that when you rotate something, make sure all the vectors are selected, or group them together or whatever, but make sure they're selected. All right, so there's my two legs. Now again, probably in here, now understand something, right? I'm going to be using an 1/8 inch end mill to cut these parts out. I probably could get in there, with a 1/16 inch end mill, and I have a 1/16 inch end mill, and I have a long 1/16 inch end mill that could reach the 3/4 inch cutting depth. But let me just show you here. My 1/8 inch end mill, when it's cutting this and milling this away, it's not going to fit in here. Okay. It's not going to fit in between these tight areas. Of course, it'll fit in here and all that stuff, but there's going to be areas in here that the bit just can't fit. And so a smaller bit, my 16th inch end mill, is going to be able to get closer to some of those areas and everything and clean them out if I wanted to. Or I could do a little bit of woodworking and clean that up with a Dremel, chisel, whatever, right? Whatever the case may be. So there's going to be some areas that I can use multiple bits on to kind of clean up. This is a two-sided job. Because of the shoulder cuts on the top and bottom tenons here, this board does have to get flipped. And so since it's getting flipped, if I were using a smaller bit that maybe had a shorter cutting flute, I could cut halfway on one side of the flip, halfway on the other, and complete that cut with a shorter bit. I don't have to have a long bit that can reach 3/4 of an inch. If I only have a 16th inch end mill, and if you don't have a 16th inch end mill, that should be one of the bits that's in your arsenal of tools. Speed Tools are great. I don't have any affiliation with them at all, but Speed Tool on Amazon, they're a great tool. You should have an 1/8 inch extra long upcut and downcut bit. You should have a 16th inch upcut bit, and you should have in 1/4 inch both upcut and downcut. But you should have in your 1/4 and your 1/8, you should have a compression cut bit too as well. And Speed Tool carries them all about $19, $16, $19 a piece. Very inexpensive but a great tool. Really, really good tool. We sell tools at Digital Woodcarver. We do carry the extra long tool, 1/8 inch, but we don't carry 16th inch end mills and all. So, it is what it is. All right. So in here, on some of the areas and stuff, I could, come in here with a smaller bit, or like I said, I'm going to probably have to do some hand woodworking as well too, and kind of do a little bit of cleanup, maybe Dremel work and all that stuff. And I'm fine with that. And if I wasn't fine with that, then I could slightly redraw these vectors before I go through all this trouble and stuff. I could, bring things in a little bit, nudge things here and there so that, my 1/8 inch bit does fit, or my 16th inch bit does fit, right? Whatever you want to do, it's up to you, right? It's all you. So just because, something, isn't like my CNC can't do it all, it doesn't mean it's the end of the world. It just means you have to use other tools or alter the design slightly so that the tool does fit in the middle, that kind of stuff, right? All cool. Awesome. All right. So, and there's only a few small areas where it will not be able to generate a tool path that are going to be easy to go in and clean up and stuff like that. Even if I had to put a coping saw in there, and use a coping saw to, I've got plenty of room here to work a coping saw in these two areas right here. And that's really the only areas it's going to be in. So either way. All right. So we got that. That takes care of the legs. Right now, let's create the tool paths for them. The 4 tenons here. Well, first, let's create our dowel pin alignment holes for rotating the board. Let's do that really quickly first. I always say that to last for some reason. We should do it now. So it's going to be a 1/4 inch dowel pin. I like an asymmetrical alignment, so we're going to just throw a one here, 1/4 inch diameter hole there. We can go here and something like that. Or we can go something like that. Either way, it doesn't matter. Either one. All right, so all of this, I'm going to select all of this, and I'm going to copy to the other side. Copy to, oh, look at there. It's not set up as a double-sided job. Let's go back and fix that. So in our sheets, this is sheet 1. which I will rename to be our legs. Remind me to save after this. I got to save. We haven't saved nothing. Let's go in and edit that. And notice on the edit here, it doesn't give me the option to be one-sided or two-sided. I can't alternate, and have this one a two-sided job, this a one-sided job, and all that stuff. I don't have that option and everything. I got to actually go back into the full design. Notice how it has the word various here, various, meaning there's various different boards of different sizes and all. But in general, I need to set it up as a two-sided job, right? So we'll touch off on the machine bed for both sides. Bottom left corner, I like flipping along my y-axis. So I'll flip along the y-axis and we'll set that up. And then once again, we'll select this, and now I can copy to the other side. Now on the other side, let's flip over there really quickly. The other side, pick which side is going to be your good side. What's going to be the exposed side, the outside? What face of your board looks prettier, right? Is that going to be side 1 or side 2? Because on the inside cuts, we have our mortises for our little supports, our center supports going through. So we have our mortise cuts that are happening and all on the inside, not on the outside. So in this case, my side 2 here is going to be my inside cut. And so those vectors will remain. And my side 1 is going to be the outside cut. So they will not be there. I mean, I could leave them there, but I don't want to confuse myself I don't want to select those vectors by accident and cut them when they're not supposed to be there, right? But you can see the outline. Oh, look here. Hold on a minute, guys. I'm an idiot. Let me make this bigger so you can see what the heck I'm doing. All right. Hopefully you kind of didn't miss any of that stuff. Lord have mercy. I'm surprised nobody was hollering at me in the chat. Let me see. I had a bunch of text messages go through. Let me see if somebody was messaging me saying, hey, go bigger. Let me see here. Nope. Wow. All right. Sorry about that. I apologize. I didn't look over my shoulder. I didn't look over my shoulder and realize that it was small. So let's really quickly flip back over here and recap. So on my side 2, side 2, that's where the mortise cuts are going to get cut. And on side 1, they're not, so I remove those vectors and everything. All right, my alignment pin holes, my 1/4 inch holes here, all of that. I've got my alignment pin holes and all that wonderful stuff. On side 2 or side 1, just because this is side 1 and the other side is side 2, it doesn't mean I have to cut side 1 first or in side 2 second, that kind of thing. Figure out, what are you cutting first? Are you cutting the side 2 vector or tool pass first and then doing the finish cut on the outside, or vice versa? It doesn't matter. Whatever mentally works for you, because your alignment pin holes on the side you're cutting first, those alignment pin holes get milled on the material, the wood. Once that side is all done, all the tool paths are cut for that side are all done, you're going to move that board out of the way and you're going to mill the side 2 holes, the mirrored holes, in your waste board. And you're going to put your dowel pins in, you're going to flip your board and press them down on the dowel pins and all, and then you're going to reclamp secure and you're going to cut that next side. So you got to just figure out what side's going to be first and what side's going to be second, because one's going to be your board side, side 1, you're cutting your holes. I'm using a 1/2 inch dowel. So I cut 3/8 of an inch deep on my board, but I only cut 1/4 of an inch deep on my waste board. And when that whole dowel is a 1/2 inch long. So that leaves me, on my 3/8 and my 1/4, that leaves me, that's 5/8 of an inch. And so I have a 1/2 inch dowel that leaves me 1/8 of an inch. So I'm not bottoming out, right? And all that stuff. And so figure out what you're doing. So for me, side 2, I'm going to do all side 2 work first. All the little mortise cuts and all that stuff and everything. So this is going to be my 3/8 inch board holes they carve on my board. And side 1 are going to be my waste board holes. So it's very important. All right, so let's select those 3 holes. And for the tool path, it's going to be a drilling operation for me, and it's going to be 3/8 of an inch deep, 1/4 inch end mill. I'm going to use pecking, and this is going to be my board or first cut, whatever you want to call it. Board alignment holes is good. Alignment holes, 0.25 end mill. We're almost getting there. We're almost getting there. Calculate. All right, so that's going to be kind of the first thing that happens, right? So that cut there. So those 3 holes. Cool beans. All right, so now the next cut is going to be my mortises here, and we still got a couple of vectors that we got to draw for our tenons here to cut those shoulder cuts and all that stuff. But our mortise cut's going to be next, and they are going to, if you remember now, it's very important that we pay attention to ourselves and all that stuff. These legs are, they're on a 3/4 inch board, and I like my mortises to be, and my tenons to be about 3/8 of an inch on a 3/4 inch board. I like half of the board thickness, right? So on this one, it's going to be a pocket cut. We're going to go 3/8 of an inch. I'm going to be using an 1/8 inch end mill. And this is going to be my support rails mortises. That's fine. 0.125 end mill or EM, whatever you want to do. Okay. So that's going to create those cuts. All right. Now, here on the profile cutout, this is what I was talking about. It's a 2-sided job. So if I wanted to, I can do half the cut on this side. And then on the other side, the flip side, I can do half a cut on the other side. If my bit, if I had a small micro bit, that just didn't have a long cutting flute, I can cut halfway on one side, halfway on the other to complete that cut and everything, whatever you want to do. I do have a 1/16 inch end mill that could do a 3/4 inch cut. It is cutting it kind of close to the shank and everything. But I'm going to run my 1/8 inch bit, and then I'll see if I'll decide mentally if I want to run another cut, on that. But what's important right now is I need to create the vectors, because I'm going to be using my 1/8 inch bit to create my little shoulder cuts here. Okay. My little shoulder cuts. Now, another thing, it's important, and I call them shoulder cuts, but it's really the 2 faces, right? The 2 faces are getting cut. And what's the proper term, ladies and gentlemen? You have to forgive me. I'm a woodworker, but I'm losing them all. I call them shoulder cuts, but it's I'm milling in the face of the tenon. Now, normally the shoulder cut is this cut right here, and this cut right here is the shoulder cut. The face cut, is it a face cut? Is it still considered a shoulder cut? I don't know. But anyway, I need to draw those vectors in there. So it's the vector for the pocket cut. It's going to be a pocket cut that's going to mill that off. So here I need a vector that's going to just be slightly larger than my actual tenon, so I can run a little pocket cut in there to mill that down. And I'm only milling it if you remember, I offset inward those tenons. on these tenons right here, if you remember, on the rectangle that I originally drew them off, they offset them in that 0.08 inches and all. Probably going to do the same thing for these. These are going into that base plate and the lid. So if any of you know the name, is shoulder cut a good, when I say shoulder cut, do you understand what I mean? Or is there a proper term that I'm missing? For some reason, I don't know why I'm drawing a blank on that. But I just need a little bit of a rectangle here so my bit can kind of do a pocket cut and mill this face off a little bit. On both sides, it's going to be milling, this face off. So whatever I draw here, I'm going to hold down the control key so I can drag a copy out here. But whatever I draw here, I want to make sure that I'm, copy them to the other side because I got to do the little face cut on that as well. All right. Do you need a right and a left on the mirror, on the legs? So yes, I do. If this is going to be the inside here, then one of these legs should be mirrored, right? And so this, I'll pick this leg. Let me turn off the create mirror copy and turn off the flip about job center, and let me just flip it horizontal here. It should be facing this direction. So it's a mirror, and I'm glad. Thank you, Jetty Vandal, for that. Thank you. I always kind of get myself in trouble with that. I did that. I didn't mirror the little router table project I did long ago. Screwed myself up. So thank you for that. But yes, if my mortises are going to be on the inside for those support beams, right? And I want my good faces, out. Well, gotta have that mirror. Look, and thank you, Jetty, for that, catching me on that one before it was too late. Otherwise, I'd have been like screwed up. So that's important. Now that I mirrored that, give me a second. Let me flip this over, and I'm just going to get rid of this for a moment. And I'm going to copy this. Not that. And not this yet. I'm not ready to copy that yet, but I want to copy that to the other side. Okay. All right. Now we're tight and right. Thank you again, Jenny. I appreciate that. All right. So now we're tight and right. So now, once again, coming back to our pocket situation here, I'm going to hold down my control key and just snap to there. All right, now I should be able to take this, and what I'm going to do is I'm going to take a line, and I'm going to come to the center of this tenon. Where are you tonight? Right there. And I'm going to go all the way over, straight across here. And I'm going to take that line and I'm going to mirror it, create a mirror copy, flip about job center, and flip it vertically down here as well. Because what I'm going to do, and I need to create a mirror copy. Let me do that again. Mirror copy and flip vertically. The reason being is when I get my 4 rectangles here, I'm going to take those 4 rectangles and select them. I'm going to select the line last, and I can align to that last item up and down. So it will center them on that line. So they will be centered on that line up and down. And I need this one too. I forgot to draw this one. So select that and a line up and down. There we go. All right, so those are all in line with each other. And I could verify that by taking this line and snapping it up here, and it should be the top of each one of those, you know, kind of deal, right? All right, so with that, I can now take those 4 objects, now that they're aligned, and I can mirror them, create a mirror copy, flip about job center vertically, and that's fine for the top and the top here, but it's not fine for the bottom. If you remember, one side's shorter than the other, so it doesn't work for the 2 middle ones. That's okay. The 2 it does. But I can take my line here, still use my line. I can still snap to the center there. Select those 2. Hold down the shift key, select that line last, and align up and down, right? Get those positioned. So the line is only serving a purpose for alignment. All right, the line is only serving a purpose for alignment. All right, let's get rid of those lines. Now, these are mirrored copies of the other side. So I should be able to select those 6, 8, 2, 4, 5, 6, 7, 8, and copy them to the other side. And if I flip to the other side, they should be right where they belong on the other side. Okay, those are my pocket vectors. All right, so now let's turn off the guidelines. Y'all still tracking with me on that? Now, I don't know why I started saying tracking with me. I said that today to someone on the phone. I was like, you know what? I like that question. I'm going to start asking that question a lot. Are you picking up what I'm putting down? All right, let's select all of these. We're going to do a pocket cut. And let's think about this now. This is important. Very, very important. My rails that are not my rails, sorry. My top and bottom, top is 3/4 inch thick. That bottom is only a 1/2 inch thick, right? And that's fine. That has nothing to do, this cut that we're doing right now has nothing to do with the thickness or the depth of the mortise. It has to do with the width of the mortise, right? So on this, these boards are 3/4 of an inch, okay? I'm going to, my tenons, I'm going to be milling both sides of them down. That's what the pocket toolpath we're about to create right now. I'm going to be milling them down slightly so the tenon is slightly less than the mortise. And then remember, I want to go 0.08. I want that to be offset 0.08. And once again, where that number was derived from earlier is this. Bear with me a second. Offset outward. Okay. If you remember earlier, it was based off of the board here. The tenon, you know, is 0.8 of an inch inward. Now, when I offset at that 0.8, if we measure vertically, I'll just measure vertically, from here to here, it's 0.08, sorry, in on each edge, not just, it's not just, it's 0.08 on each edge, not just 0.04 and 0.04 for a total of 0.08. You know what I mean? It's 0.08 in on each edge. So I don't want to confuse you. That's where that number is coming from. Because remember, when the dog bone fillets get cut on the mortise, the board has, here's the tenon. Let me draw the tenon for the board so you can understand. Okay, and let me drag this out so you can see it without the dog bone in the way. This represents the full board with the tenon. So this inside rectangle represents that tenon. Okay. And so the shoulder cuts that I keep talking about is the material that, you know, is gone from here, here, and then the two face cuts and all, so that the tenon fits into that mortise. And when it fits into that mortise, the actual board itself, the edges of the board, the faces of the board, cover that, conceal that whole mortise. It's covered and gone. And it even covers and it clears the, you know, the little offsets, those little fillets and all. And so that 0.08, since I'm using a 1/16 of an inch dog bone fillet, the 0.08 just gave us that room, that clearance, you know, so it does cover it completely. So hopefully that makes sense. And so the same principle applies for this. So these are my tenons, and right now this tenon has a overall length of 1.25 inches. The height of the tenon is 3/8. So that's how deep it's going to go into the mortise. And that means that my mortise on the bottom side of the lid, the top board, you know, and the little foot panel and all, it's going to be it's going to be 3/8 of an inch deep on the top part. On the bottom part, it's only going to be I'm using a 1/2 inch board, so this is going to be a 1/4 inch. And that reminds me, I got to fix that. All these things are starting to click now. I got to change the size of my 2-foot ones. But anyhow, we'll focus on just the tops right now. This is the top. So 3/8 inch deep. So the mortise that gets cut into the bottom side of that top part is, the tenon's going to fit in there. It is 1.5 inches or 1.25 inches, sorry, 1.25 inches, but the width is going to be my 3/4 inch board minus 0.8 and 0.8. Okay. So long story short, my pocket cut that I'm coming here, it's going to be taking 1/8 of an inch off. Not 1/8 of an inch. Come on. 0.08. 0.08 and 0.08 off on each face. So let's create the pocket cut, and you'll see this in just a second when we do the 3D view. It'll make sense in the 3D view if it doesn't right now. So here, my pocket depth is going to be 0.08. And I'm going to be using an 1/8 inch end mill. And it's going to be here and here. Here and here. Now, it's still going to be an 8.08, you know, off of these faces here, but I got to change the size of the length of this these tenons on the bottom. But it's still going to be 0.08 off the faces. But these are going to be shorter because my bottom plate is only a 1/2 inch plate. I did go with a 1/2 inch plate on my bottom plate, right? Let me see. Sheets. Yeah, 1/2 inch. I sure did. Okay. All right. So I'm going to calculate those. These are going to be my I'm going to call them shoulder cuts, whatever they are called, but I know the shoulder cuts are on the edge, but I'm going to call them shoulder cuts. Now I'm going to have to go back and re-educate myself on joinery. Shoulder cuts. I don't need, I'll know this. 0.125 in mil. All right, calculate. So that'll be those cuts. Okay. Now, before I forget, I want to go over to the other side, and I actually want to delete all of this on this side, except for my 3 alignment holes. I want to delete all of this. I want to get rid of that because over here, I'm going to fix these tenons on the bottom feet here, and I'm just going to copy them back over to the other side. That way everything is clean and tight. All right, so here, first thing I'm going to do is go back into my fillet tool, and I'm going to remove these fillets by putting the mouse over them and just clicking. I'm going to remove those fillets. All right. Now, the size of these here, these are connected to this. And so I have 2 choices. One, I could cut them loose from that node editing and cut the vector and then resize them and reattach them, or just resize them in node editing. Right now, they are 3/8 of an inch from here to here. Okay, I need them to be 1/4 of an inch. So I just need to remove 1/8 of an inch. So all I'm going to do is in node editing, I'm going to select these 2 nodes right here. They'll turn red. And all I have to do is move them in, stop moving the mouse, keep the left mouse button held down, move them in the direction I want them to go, which I just did, and type in the distance I want them to move. So in this case, 0.125, and hit enter. It's going to bring it in that 1/8 of an inch. So now I should have a 1/4 inch tenon, right? Okay. Same thing, rinse and repeat. So let me close this. Node editing. Select these 2. Grab one. Pull it in. Keep it on your line. Pull it in a little bit. 0.125. Enter. Up here. Grab one. Drag it in. 0.125. Enter. Select this. Drag it in. 0.125. Enter. All right. Now, I don't care about this. I've already made the pockets on these. I don't care the big. That's fine. It's just a pocket. It's taken off that face. So they can stay. But I do need to put my fillets back in there. So the T-bone fillets, not dog bone, T-bone fillets. So I need to put them back. These rectangles out here, these rectangles are that's the rectangle that the pocket cut is being, that got calculated on, so that it mills off that 0.08 off the face of this. Okay, so I got my fillets back in there. All right. Once again, had to reduce that down because my bottom plate that they're connecting to is only a 1/2 inch thick. So I needed a 1/4 inch tenon here. My top plate is 3/4 inch thick, so I'm going with a 3/8 inch tenon there. Now that I've corrected that, I'm going to select and I'm going to copy them back to the other side. Okay. All right. So here's what I should have on this side. I should have my alignment hole cuts, my rail mortise cuts, my shoulder cuts. And if I wanted to, I could go ahead and do a profile cut, cutting these parts halfway through. Or I could do it all the way through on the other side. Totally your choice, whatever you want. Let's just do it. We'll do a halfway through cut. We'll do a halfway through cut on this side. Let's select this so we can move on. Make sure all the vectors are selected except for the two mortise grooves and all these 4 rectangles. So all the other vectors are selected. Wonderful. Profile toolpath. We'll cut 3/8 of an inch on this side. We'll use an 1/8 inch end mill. Cutting on the outside of the line. Now the software is smart. It knows that there's inside vectors here. And so it reverses the cut. It's going to cut on the outside of the line. But when it gets to these inside cuts and everything, it'll do inside cuts on them where it's necessary, these cuts here. And again, it's only going to cut where it can fit. So it's not going to, I'm not going to have those nice sharp corners and all that stuff. And I'm really, again, I have a Dremel, right? If I wanted to clean them up and all that stuff. So no tabs are necessary because I'm going to be using two-sided tape or something like that. But if I wasn't, then tabs, absolutely. So that way tabs are cut on both sides and they meet in the middle, right? So if I were to do tabs, let's just do tabs to make it sense. I want an 1/8 inch tab altogether. So a 1/16 of an inch thickness on each side. The width is 1/4 of an inch. That's fine. And let's go ahead and let's throw a tab somewhere I can run my flush trim bit on really easily. There, and then here, and there. All right, calculate that. Okay, so when we preview this visible toolpath, you can see here in the middle where the areas where, you know, it's not, that bit's too big to fit, right? So if I wanted to, I could come in and isolate this area and have a 1/16 of an inch also come in and try to run and clean up some of this or fit where it can, or at least give me some kind of outline. If I it could at least, if it at least gives me a path to where, you know, to cut my Dremel or whatever the case may be. It's still not going to fit in these tight areas, but it might fit in others and all. So I could come in here and copy this to another layer. This will be my 0.0625 inside cut vectors. I'll make them red. I'll come in here and turn off everything else, so I'm only seeing these copies here. And I'll go into node editing. I will cut the vector here and here. Here. And I could smooth this up to reduce my run time too. We'll talk about that in another class. Cut the vector there. Over here. Rinse and repeat. All right, on this layer, all I need are these inside parts. Bear with me. Let me cut the vector right there. All I need are these inside lines. This one and this one. This one and this one. Oh, that one's still attached somewhere. Give me a second. And everything else can go away on this layer. On this layer, I can get rid of everything except for those two lines, this line and that line. Same thing here. I can get rid of everything except for those two lines. Now, it's important. I'm going to be cutting on one side of the line here, a profile cut with that 1/16 of an inch bit where it can fit. You know, it's only going to go where it can go. There's also, I mean, hell, if I wanted to, I could go down. I mean, I got a tapered ball nose that tapers down even further than that if I want to use a smaller bit. Whatever you want, right? That kind of thing. But it's important that I'm cutting on the correct side of the line. And when I come in here and do another profile toolpath and I choose, I'll go 3/8 of an inch, but this time with my 1/16 of an inch end mill. When I'm cutting, I'm going to cut on the outside of the line, outside right of the line. If I calculate this, first of all, let me select the vectors. Where my vectors start and where they end are very important. Right now, if we look at these cuts, and I'll go to solid view to make it easier. Here, I'm cutting on the correct side of the line on this vector, cutting here. And on this one, I'm cutting on the correct side of the line. To clear out that area. But on this side, no, this side's good too. If I were on the, let's say that my start point on one of these vectors, let's say that my start point was on the other end here for the moment. And let me recalculate that toolpath. You would see that that cut is on the wrong side of the line. Okay. And on that cut, that's the wrong side of the line. I don't want to cut on that side of the line. So it's very important where your start points are. And in this case, all the start points happen to have been on the correct side. Okay. Now, preview the visible toolpath. Okay. And so the areas that couldn't, you know, this little area, this little vector right here, this little area right there, because I'm doing a profile cut and not really a pocket cut, it's leaving that wood right there. But that doesn't matter to me because it's going to get cut out. It gets, when this thing gets cut all the way through on both sides, that's one of the offcuts, right? So that part and those parts there, those go away with the waste and everything. But I'm able to, I did overcut right here slightly, and right there, it did overcut and everything, but I can, a little bit of sanding, I can kind of clean that up and you wouldn't even know that was the case. But so that 1/16 of an inch bit gave me the, you know, the clearance I want, you know. And if that was the case and everything, if for whatever reason I just wanted to use one bit, I could use the 1/16 on both sides. I don't have to switch to the 1/8. But in this case, I just want it to the 1/16 just to, you know, do what it does. It doesn't matter that I'm running the same toolpath twice, you know what I mean? All right. So with that, I'm fine with. Now, this is important that these vectors get copied to the other side as well. on this same layer. So copy to the other side. And it's also very important as a whole it's also very important as a whole that this vector and this vector get copied to the other side again because it has the placement of the tabs. So I'm going to flip over to the other side for a minute. I'm actually going to delete that profile and that profile again, because I'm actually going to take these profiles and recopy them back over. Oh, don't do that. Bear with me a second. It's very important. Once again, on the other side, these profiles, they have the placement of the tabs in them. So I want to copy them over to the other side. And when I copy it to the other side, it'll copy the tabs too. All right. So on these vectors here, I should have, if I turn off the red ones right now, I should have complete full vectors of the legs here and here on one layer. And then the other layer should be just the lines. And that should be true on the other side as well. I should have just the lines and the complete vectors. So on the other side here, now this is the side, these holes get cut on my wasteboard. Wasteboard. We're almost done, ladies and gentlemen. I haven't saved anything. Let me save real quick. File, save as. We're almost done. We only have 4 more mortise cuts to do in just a second. So blah, 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 blah. File, save as. And I'm just going to call this dog stand. All right. On those 3 cuts, drilling operation, 1/4 of an inch deep on the wasteboard, 1/4 of an inch deep using a 1/4 inch end mill. I'll use pecking, but this is going to be my waste board alignment holes. Wasteboard, 0.25 end mill. All right, calculate that. Okay, that's going to be those cuts. Now, same thing, my little pocket cuts here. 0.08 inches deep. That mills off the little face of those tenons. Pocket cut, 0.08 with an 1/8 inch end mill. This is going to be my shoulder cuts. And when I save the toolpath, it'll save as side 1 or side 2. The side will be on there. So shoulder cuts, 0.125 end mill. That'll be those. Those shoulder cuts will make sense when we do the final cutout here in just a second. You'll see the whole part. All right. My mortises do not get cut on this side. Remember, they're only on the inside. So those vectors get deleted. The reason why they're there again is, if you remember, I deleted them and I copied everything back over. Okay. So just those cuts. And then the final cuts are my profile cuts. So we will do the 2 main profiles. they're going to be a profile cut, cutting 3/8 of an inch deep with an 1/8 inch end mill. Outside of the line, tabs. The tabs are already there. That's why I copied that profile over after making the tabs and all, recopied it over. And this will be my profile cutout. Now, I want to run that 1/16 of an inch bit first and this bit last, because this is going to cut it all the way out. So this is going to be my last cut here, 0.125. So I'm going to move it down in my list on this, but that's going to cut out completely. But I had that 1/16 of an inch cut. Let's go in here and turn the vectors off for a minute. And on these lines, let's turn off the toolpath so you can see. On these lines here, that 1/16 of an inch profile cut, again, cutting 3/8, but with the 1/16 of an inch bit. Outside of the line, I don't need tabs because this is not cutting all the way. No, you know, I don't need tabs in there. So no tabs on that. This is my kind of clean up. I don't know what I want to call it. I forget what I called it on the other side. Cleanup profile 0.0625. I'll come up with a cool name for it later. All right, calculate that. Again, looking at this carefully, notice here I'm on the wrong side of the line on this one. So when the part got flipped this time, so did the vectors, right? When they got mirrored and flipped, they're on the wrong side of the line, unless I've chosen the wrong thing over here, which I didn't. So they're cutting on the wrong side of the line on this side on both of these cuts. So I have to go in, it's very important, and I have to make this my start point, make this one over here my start point on that lower line, make this end of the line my start point, and make this end of the line on the start point. Let's recalculate that. So it's very important that we're cutting on the correct side of the line, you know. Now, what I was talking about when I talking about cleaning up, there's a slight little bit of an overcut here when this 1/16 of an inch end mill comes in on this line and then comes in on this line. You know, it's not treating it like a pocket cut. The reason why it's cutting on the outside line, because it doesn't realize that there's another vector there, because they're not connected together. It's just doing a profile cut on the two lines that I have selected. So that 1/16 of an inch bit is coming here and it's kind of running into this, and the other 1/16 inch bit is coming into here. And the that tells me that I could just do one line and not the other, because I don't need to cut on the line where the big area is. I just need the bit to try to cut and clean up somewhere in here, right? So I could technically on this and on both sides, I could choose what line I want to cut and what line I don't. So, but I could choose and pick my battle, but it doesn't matter. I'm still going to overcut on one area or the other, right? Somewhere I'm going to get, there's going to be an overcut, no matter if I choose the line or not. When this bit cuts along this line, it's still going to cut into that tooth, whether regardless of if I'm cutting that line or not. But that's one area that I need to clean up and kind of reshape lightly. You know, you won't be able to notice it at all. But the other area, I wouldn't have to, right? If I recalculated this, with just one of the lines, you know, it's going to cut on the line perfectly on this tooth, and it's going to slightly overcut here on this tooth, and I would have to just do a little bit of cleanup and everything. But now I don't have two lines fighting with each other and all that stuff, and it's still going to clean out and get where I need to get, right? So it'll still create that. And if I'm going to do these two, when this flips, remember now, those two lines, when they get flipped, they're the top lines on the other side. So if I'm going to do that, I want to make sure I'm cutting the same line. So if I do that, which is fine, I think that's going to be a better idea. I want to make sure I go back really quickly while it's on my mind, flip over to the other side, open up that toolpath cut, and it's the top lines I want to keep because it's mirrored, right? It's flipped. So I want to turn these off and recalculate. Okay. So that way I still achieved what I wanted to achieve with that smaller 16th inch bit. But I'm not fighting with two lines and having to clean up a whole lot. You know, only some of my teeth I need to be just kind of reshaped a little bit slightly. All right, so here on side one, I need to make sure that my profile cutout is last in the list here. And just for preview purposes only, I'm going to turn off the tabs and recalculate both sides. So that way we can cut out the parts, view all sides, preview all sides. And I can get rid of that waste. Right here, I'm missing those cuts on the other side to cut all the way through. So I got to go back on the other side to look at that. Okay, so now let's look carefully at this. Let's zoom in here, and you can see those shoulder cuts, right? I call them shoulder cuts, but you can see that 0.08, you know, shoulder cut on both sides of that tenon. Okay. See that there? That way, when those tenons go into the mortise and everything, this board right here, you know, conceals everything and hides all that joinery and stuff. So that's what we, you know, that's what we faced off there, that 0.08 on those tenon cuts. All right, so yeah, so much cleaner. I only have a little bit of Dremel work to kind of just smooth out this area here and right here. You know, a little bit of sanding, Dremel, whatever I want to use to get in there and kind of clean that up. But still going to give me a nice look. There's my pockets on the inside there for the two support rails. There we go. All right, ladies and gentlemen, we're almost done. Let's hit save again, file save. Let's switch over to our other board really quickly. In this case, let's go with the stand top. Let's go with our top board here. Flip back over to the other side here. Okay. Now, if you remember, I simulated that top there and everything, and I kind of drew lines where the center of those mortises are going to be, right? And this is my top here, the whole top. This is the size. It's the size of this board is 24 inches. I believe it's 24 by 11 and a quarter. Let me look at sheets. Yeah, 24 by 11 and a quarter. And in here, I'm going to have those 8 1/4 inch holes. Both of the bowls are the same diameter. Remember, they're 8 1/2 to the outside edge, but 1/4 inch on the lip. And that's going to have to be doubled. Let me just do I'm going to do an 8 1/2 inch bowl circle here for a minute. All right, let me mirror that over. Okay, so here, that's my bowl. That's the actual full perimeter of the bowl. And I'm going to offset these two inward 1/4 of an inch. That's the size of that lip. Offset inward 0.25. I will confirm on that. I will confirm on the actual bowl before I do the final cut and everything, but it should rest right on that lip. And that's going to be my cut. I really don't need these vectors. They would only, tend to confuse the situation. These are centered. I am centered there. So that's those cuts and all. Well, if you remember here, this represented the top. And so if I rotate this 90 degrees and I, kind of grab this and I snap this to the edge here, now I need to figure out where I want my legs to be, right? So my legs are 3/4 inch thick too. So this could kind of represent the leg, but I need to figure out where I want my legs. Do I want a little bit of an overhang and all that stuff on the inside? And I do, I really do. But I don't want to collide. I don't want to be too close to the hole for my bowl. You know what I mean? So I probably, let me see what my overhang is there. Okay. So what I'm going to do is let me get rid of that measurement. I'm going to select this. I'm going to drag it back and snap it here. And I'm going to move it inward. Move. I'm going to make a relative move from the right side. A relative move. I want to bring that right side in 1/2 inch. Let's go 5/8. Let me hit undo on that. Let's go 0.625. Wrong direction. Negative number. Negative 0.625. I'm good with that. All right. Let me mirror that to the other side. Okay. Now, those lines simply represent where the center of that tenon is. And those tenons, ladies and gentlemen, on my top, they're 1.25 inches long. All right. So my rectangle, if you remember, my leg is 3/4 inches wide. And, there's going to be 1.25 inch long tenon, right? So, but remember, 0.08 and 0.08 off in. So I'm going to offset this inward 0.08 sharp corners. And this, I'll just grab the whole thing here. This would represent that tenon. And I'm going to just select it. I'm going to snap it there for a second. Bear with me just a minute. This will make sense in a second. Hold down the control key and snap a copy of that there. Now, I'm going to select both of those copies. They are grouped together, these two lines, but I'm going to select this line last because that does represent my 3/4 inch leg, right? And I'm just going to align to the center, left to right, of that last item. And this is my vector, the inside, not the outside. The outside is, the actual wood. No, that's my vector. And so let me ungroup those. That vector, again, is 1.25 inches. Needs to be 1.25 inches. I resized that. Needs to be 1.25 inches tall. Come on now. 1.25. All right, let's get rid of that rectangle so it doesn't confuse you. The line, this just represents where the center snapped to. That's all that it served its purpose. Okay. So on those two vectors, they will get copied to the other side, mirrored to the other side. Okay. And then our dog bone fillets. So let me undo that mirror. Why mirror what you can copy, or why draw what you can copy? So let's do our fillets. Not T-bone, dog bone. Now I'll copy those, mirror them to the other side, flip them horizontally. All right, so that's the only tool pass on this. I really don't need this to be a two-sided job on this one, just one side, because my pocket cuts here, they're going to get cut 3/8 of an inch deep. That's my mortises. So 0.375, I'm going to be using an 1/8 inch end mill, which gives me a 1/16 of an inch radius. That's the same as my fillets there. This is going to be my mortise cuts. So my top board mortises, 0.125 end mill. That's it for that cut. Calculate. And then these two will get cut out all the way through. I'll use a 1/4 inch end mill. So they're going to be a profile cut, cutting on the inside of the line all the way through the material. We'll throw some tabs in there. This will be my bowl holes. 0.25 end mill. Calculate. All right, so that's the top board done. Okay, for right now, let's turn off the tabs. I'll come back and put all the tabs in just a minute. Re-preview that and click that away. So that's going to be the cut for the bottom. Now on the other side, I'm going to just run it the other side through a round over. I'm going to soften up the edges, and I got a round over bit on the router table. I don't need to do it on my CNC, but if I did, then, I could do it on the CNC as well too, but I don't want to have to flip this. Just one cut, one side. I'll run it on. It's faster for me to get it done, my round over bit on my other router station and everything. So that's going to be the top board. Okay. If I wanted to, I could V-carve, do some fun and creative there and make it look decorative, whatever the case may be, but I don't want to right now. So right now I want to come back and focus on this one. All right, now this one is my bottom board. And remember now, my bottom board is only 3 inches wide. Now this board is wider than that. It's a 1x4, 3.5, but I'm cutting only a 3-inch by 11.25 inch board out of that. So the rectangle that I'm about to draw here, I want a height of 3 inches and a width of 11.25, and I need it to be centered here. So I'll just put my mouse there and I'll click to drop it there in the center, or I could have come up here and found the center by taking my x-axis, dividing it by 2, and my y-axis and dividing it by 2 to get my, center point. But it's just as easy for me to move over there, snap to my smart snapping, and left click. So on here, this represents, if I center, let me group that, G for group. If I bring that down and center that on the board, right, the overall length on this one, I had the length at 10 3/4. 10 3, that's very important. It is 10 3/4. So this rectangle needs to be 10 3/4. I remember I said I didn't want it the same length as the top of my board. So 10.75 by 3 inches. There we go. And these lines represent where the center of those two mortises are. In the center of those two mortises, if we flip over here real quick, the bottom mortises, they should also be 1.25 inches. They should also be 1.25 inches in length. Yep. Come back here. Final cuts, final toolpath. Then we can say our goodbyes. 2.5 hours in. Okay, so we take our rectangle. Our legs are 3/4 inches wide. The actual leg that's going in there, the leg, not the tenon, and it's 1.25 inches wide. Okay, so this represents the center. And now I'm going to offset this, but I'm only going to offset this on one edge because it still stays the 1.25 inches. So I'm going to offset that. I'll go ahead and offset it all the way around. Just it's easier just to kind of offset it inward with sharp corners, right? But the length of these remain. Now it's only the two shoulder cuts. The length of them remain that full 1.25 inches. So I'm just pulling this out and I'm snapping to that corner so it stretches it out to that length. All right, so again, so it doesn't confuse the situation, get rid of the outside vector here. That just represented the width of the wood. On here, I've got the placement now and everything. I don't need, let me ungroup that and get rid of those lines. I've got it centered kind of right on that edge. Now, if I select these two items first, hold down the shift key, select this item last, and align up and down to that last item. Okay, that represents the center of that. And technically, I need to be centered of this big one, not that one. So align up and down, center there. There we go. I got to be centered on the foot plate. Foot plate, very important. Now, there doesn't have to be a left and right on this. They're both the same. Let me see if that's true. Yeah. So all I have to do, I just need this one set of tool paths here, and I can just cut it twice. So pocket cut. First of all, let me put the fillets on there. Okay. Perfect. All right, so the two pocket cuts, they're going to be cutting 1/4 inch deep. Now listen, your tenons are 1/4 inch wide. if you want room for glue space and all that stuff and everything, you can cut your your mortise just slightly deeper and everything. And you could account for any anomalies or anything like that by going just a little deeper so it doesn't bottom out, that type of thing. Whatever you would like. In that case, in that rational thinking, I'm just going to give myself 3/1000ths of an inch. So I'm just going to cut 0.253 inches deep. In that rational thinking, I should go over to the top and do the same thing, give myself a little bit of glue space on that and everything. But the 3/1000 is just about a human hair. So I'm just giving myself just a little bit. I'm going to be using an 1/8 inch end mill to cut that. It's going to be my foot plate. Mortise is 0.125 end mill. Calculate. Now, if y'all stay with me till the end, I'll create a link for this file and I'll upload it. And I'll put a link in the chat that you can download it, or it'll be in the, we're almost done. We're 2 seconds away from being finished. So here we have our final profile cut, cutting all the way through the material, 1/2 inch, 1/4 inch end mill. I'll use a 1/4 inch on this one. Cutting on the outside of the line. We will add tabs, but for right now, preview purposes, I'll leave that off. Calculate, preview. Okay, and flip that over. All right, so that's going to be my foot plate. Okay, that's it. So that's the 2 tool paths for the foot plate. The 2 tool paths for, or the 2 tool paths for the top. Right, for the cutout. That's the top. And then all the tool paths for the legs. Preview all sides. The alignment holes, this and that. The wasteboard alignment holes. And then, our leg parts. All right. So I'm going to hit File, Save. And I'm going to save this as, I'm going to go File, Save As. And I'm going to save it as an Aspire file dog stand, but I'm also going to save it as a VCarve file. Save as VCarve, because there's no model files in there. I'm going to take both of those files, both the CRV 3D and the CRV. I'm going to compress them into a zip folder. I'm going to upload that zip folder to my Google Drive. Give me 2 seconds. Google Drive, Spindle TV files, drag and drop. I'm going to turn on the locating the file. Share, anyone with the link. Share, anyone with the link. Copy that. Here we go. Go into the download link generator tool. Paste that link and create a new one. Copy. All right, in the chat, ladies and gentlemen, in the chat is the link to download that file. And inside that file will be the Aspire version and the VCarve version of what we have right here at this point, if you want to make something like that, right? If you do make it, I want to see photos. All right. I'll share my photos. All right, everybody. We are done. That's it. So that is it for this project. That completes this task. And thanks for sticking with me. Thanks, Chris. I know you were fading fast. But again, Jetty, thanks for reminding me to mirror the part. That would have been a big old screw up and all that stuff. But there's your files in the chat. You can click on that to download them. Instant download. And I don't know. Maybe you can resize it for cat stands. Who knows? All right, something fun, something simple, you know, and all that wonderful stuff. It could be carved out of all kinds of materials and contrasting stuff and all that. But I hope you have fun with it. I hope you can use it for something. I hope you learn something. And until next time, I'll see you soon. See you, everybody.